This is Lesson 2, Matter Can Change, from the Investigating Chemistry unit. Today, students are going to start with the lids that they have left over from Lesson 1 in that experiment. We're going to finish that experiment today. The students will notice that both of the lids have a white powdery residue from the evaporation, but they shouldn't be able to tell just by looking which was the vinegar and which was the water. Of course, they've written it on there so that they can keep track and so they understand how to interpret their results, but they should find that they look pretty similar. The next thing students are going to do is they're going to take a pipette with a little bit of vinegar and place a few drops of vinegar on both lids and make observations about what they see happening. The one that had vinegar should have no reaction. All of that reaction should have already taken place when the vinegar was originally added to the baking soda. It is possible that you may have a small reaction on a couple of them. That would be a result of not all of the baking soda mixing with the vinegar during Lesson 1, and talk about how that's an important reason that we did the stirring with the toothpick and making sure that a little more vinegar was added at the end just to make sure that reaction was complete. Even if there's a little bit of reaction, there should be enough difference between the two lids that they can still see that things happened differently with the vinegar than they did with the water. When the students add the vinegar to the lid that had water and baking soda, they should see a bigger reaction, definitely more like what they saw yesterday with the vinegar and baking soda. And you can talk about how that's evidence that the vinegar and baking soda in Lesson 1 went through a chemical change, whereas the water and baking soda simply went through a physical change, and now the chemical change is happening with the vinegar. Again, this is a great time to talk about the differences between physical changes and chemical changes. Have students come up with a lot of different examples of each of these. And then there is a place in the student workbook for them to apply this knowledge in looking at examples and determining what kind of a change they have gone through. The next part of this lesson is going to allow students to look at a different type of evidence that a chemical change has occurred and allow them to design an experiment on their own. So they're going to use their student workbooks, and they're going to use a thermometer and temperature change as evidence of a chemical reaction or a chemical change. You'll want to let them know that this does go pretty quickly once they start. So in their groups, they're going to need to determine several things: how much of each material they're going to use. They're going to need to determine how they will keep track of their data and how often they're going to check the results and check the temperature change. You can talk about how, because this is a fast reaction, probably they don't want to wait 3 or 4 minutes to check the temperature from start till their first check, because everything will have already occurred and that's too much time. Also, 1 second is probably too short of a period of time to get meaningful results. So they need to determine within their group what time frame that they want to use. They are going to be graphing their results, so they need to have a consistent time period that they are using to check those results. The graphing activity is a great way, again, to bring the Math Common Core State Standards into your science lesson. You can talk about what goes into the graph, how to create the graph, and then interpreting the results on the graph later as well. It's up to you how much freedom you give the students in designing this activity. You may have a class who can put it together very quickly, who are very inquisitive and want to find all of the steps of the process. You may have a class that needs a little more guidance, and you may have different groups within one class where you need to differentiate and give a little more leeway or a little more guidance to one group or the other. And you have the freedom to set this up the way that's going to work best for you and your students. If you are giving the students the suggested measurements. I'm going to give you measurements that we have found worked well for this. I'm going to start with 3 scoops of the water, and the water is necessary just to raise the level of liquid in here so that the bottom of the thermometer is in the liquid and can record the temperature change, but the water doesn't really change the results from the reaction. You'll also, depending on your cup or the thermometer that you're using, you may need to add a little bit more water than that, and I'm going to add a little more water. Okay. And then we found that 1 scoop of vinegar and 1 scoop of baking soda is good for getting the results. So remind them that they'll want to take a baseline measurement, and then they can put their scoop of vinegar in, record their baseline at this point, and then 1 scoop of baking soda. And remind them that as soon as that baking soda gets in there is when they're going to want to start recording their time. And you can stir that up a little bit to make sure that the reaction occurs. And then they'll just want to watch the temperature change. Remind them that we are graphing this and we're looking at a change over a period of time, so they'll want to take more than just one collection of their data. They won't immediately put that onto their graph. They're going to put that somewhere else so that then they can use that data and transfer that into their graph. Again, really great practice on their graphing skills. So working together on their timing, on the reading the thermometers, all of this is a great chance for them to work on the experiment together. Depending on the amount of time that you have and the size of your class, you may also want to have them repeat it with a little bit different amounts in their measurements and see what difference that does or doesn't make into their results. This really lends itself to a lot of inquiry-based learning and a chance for them to really work on experiment design as well. At the end of the experiment, you're going to again talk about physical and chemical changes and ask what evidence the students had for those types of changes that they observed in their lesson or in their experiment. The last part of this lesson requires you to prepare ahead of time a non-Newtonian fluid for the students, and you'll make that in a large batch ahead of time so that you can pass out small amounts of it to the student during this part of the lesson. You'll want to start with talking about the properties of liquids and ask what they remember about the properties of liquids, and also what they remember about the properties of solids. And then you're going to tell them that you're going to talk about non-Newtonian fluids, which are sort of like liquids, except that they break the rules a little bit. As they get them, have them make observations about what they see and explain how it looks like a liquid, what happens with it that would be similar to a liquid. So it's taking the shape of the container it's in. If they're tilting it, it seems to flow or pour a little bit. Then talk about that you can see the ways that these break the rules of liquid by having students use their fingers to hit it and ask what they notice about it. It doesn't splash, it's hard. These are observations they can make that kind of go against what they're used to with liquids. Allow them some time to play with this, to make observations, to make inquiries about this, and then let them know that they can take some of it home to continue to play with. And you can let them know it's really just a mixture of cornstarch and water if it's something they want to experiment with or share with their family at home. Baggies are provided so that you can send it home with all of the students as well. Thanks.